Okay. Recursive equation function notation. What is the format? Correct. Official, formal format for it. So recursive equation.
Is this on page 9 or page 10?
Page 10. Notation. I am going to steal our warm-up problem as an example of this.
Can we do a new one so we can learn different stuff?
Do you want a new one just for more practice?
Yeah.
Okay. I can make up a new one really quick and we could do it together for some more practice before your checkup tomorrow.
Yeah.
Sound like a plan?
Yeah.
Okay. Page 10. Okay, so I'm going to make up a new little sequence. We'll do another geometric sequence just for practice because we've had a lot more practice with arithmetic than geometric, right?
Yeah.
Okay, so I will come up with one on the fly for you guys here. Let's see. Okay, so first of all, do you guys see the pattern?
Yeah.
What's the pattern?
Sometimes 4.
Okay, so what's the next number going to be?
192.
Yeah, okay. So I kind of withheld that for a minute because I wanted to make sure you guys were seeing the pattern. Okay, so it is geometric. A lot of you guys just saw the pattern. I'm multiplying by 4 each time, right? So recursively, the informal equation, we know that it's going to be to get the next, I have to do the previous times 4, right? If I want to take this informal statement and put it in function notation, I've been mentioning to you guys that you have to have 2 parts to your function notation. So the first part is I need to say where I'm starting. And we'll come back in just a second and I'll remind you guys of why that's important. So recursive equation, if I'm going to put it in function notation, it needs 2 parts. So the first part it needs is what's happening at the start, and then how is it behaving? What is it doing to get from the next number to from the previous to the next? So this starts at 0, and at 0 I have an output of 3. So in function notation, I would say f of 0 equals 3, right? Input, output. Okay, and that just comes back to our intro to the format of function notation. To see what this does, this is where I'm turning this informal statement into function notation. So to get the next number, which basically is going to be to get whatever number I want, I have to do the previous number. And we've been focusing on how do I represent the previous number algebraically. So if I want x, how would I represent what comes right before that?
X minus 1.
Yeah, because whatever's before that's going to be 1 smaller, right? So if I want 3, I should look at 2, and 2 is 1 smaller than 3. So I know that I would represent the previous with x minus 1, but we also mentioned that am I multiplying the previous input or the previous output?
Output.
Yeah, so because this is an output, I need this x minus 1, but I need to say run it through the function. So I need this part with the function name and the parentheses because that tells me to look at the output and not the input. So this would be how you represent the previous output. So without the parentheses, I'm going to put a note down here. X minus 1, just that part would be the input. So if you don't have this other part around it, then you're literally multiplying the input. So I literally would be doing 2 times 4 instead of 48 times 4. And that's not what we want. We want to look at the output. And then the last part is going to be times 4. That was already translated into numbers in our informal equation, right? So these two parts together make formal function notation. The reason you need this starting value, and I'm going to come down here and make a comment about this. Watch what happens if I try and use this pattern with the first number. I want 0, right? 0 minus 1 is -1. -1 times 4 is -4, right? Did that give me the right answer? So this pattern doesn't work for the first term, which is why you have to say what the first term is. Otherwise, you would have no way of finding it. The reason it doesn't work for the first term is because this pattern is based off of whatever comes before. Is there anything before the beginning? No. So that's why, that's why you have to define the beginning of your function, because this will not work for the beginning. It will only work if there's something before it. So since there's nothing before the beginning, I have to define the beginning. So I'm going to put a little note about that just so you remember, hopefully, and it'll help you remember to include that piece, why we need it. I'm going to say, since there is nothing before the beginning, there's no previous term before the beginning. So there's nothing before the beginning. We need to include the beginning. And then the other reason why it's important to include the beginning is that the first term will not give a correct answer in the second part of the function. Okay, so because there's nothing before the beginning, I can't use this yet. I can't use this until I get down to the second term where there's something before it that I can run through this function. Okay, so the second part of the function will not work with the first term. So second part of function does not work with the first term. So that gives you something that is a little bit more official in your notebook about that recursive equation function notation, since we've been kind of informal about it up to this point.